let's talk a little bit about probability sampling and non-probability sampling. So again, this is what I think will be part of this third year of survey research. So the way many social scientists are trained, I think, is captured by this figure. So probability samples are good. You can prove nice things about them. This is from the Horvitz-Thompson 1952 paper. This is nice. Non-probability samples lead you to embarrassing mistakes. So this is President Truman, for those of you who don't recognize him. He actually won. So the source of this error was a non-probability sample. So this is kind of, and in fact, often we use sort of representative data as like a shorthand for good data and non-representative data as a shorthand for bad data. This is related to this idea. This is what many people are taught. This is not true anymore. So I would say this is a better reflection of what is currently happening. Probability samples have an unknown sampling process with weighting based on unverifiable assumptions. And non-probability samples have an unknown sampling process with weighting based on unverifiable assumptions. So this part I think many people would agree with. This part some people would disagree with, but I would then, if you think of the process, the difference between the sample population and the respondents, there's like another form of sampling happening there, right? And that sampling is outside of your control as a researcher, and it's not something you understand. So there's the unknowns. You may select the sample using all the great math in Horvitz-Thompson's paper or whatever, but then the respondents and the world create this second sampling process, which you don't understand. So we deal with that by making these kinds of corrections, but basically what we're doing is we're making a bunch of assumptions to correct for this sampling process which we don't understand. That is very similar to what happens with non-probability samples. Now you may say, well, I believe these assumptions more than I believe these assumptions, and that is a totally reasonable thing to say, and often that's probably right. But we are not in the realm of like one thing that is clearly right and one thing that is clearly wrong. We're in a realm where we have different assumptions. Some might work better than others in different situations. It becomes much more of an empirical question rather than something that can be decided by fiat. So probability sampling is roughly that every unit from the frame population has a known and non-zero probability of inclusion. So for each person, we know their probability that they will be included in the sample, and then this is really key because this helps us correct for the sampling process when we make our estimates. Not all probability samples look like a mini version of the population, so often researchers will systematically create populations that don't look like the larger population, because that leads to improved efficiency for a variety of reasons, which we can talk about. So the idea that the sample has to be a mini version of the population is not right. But even if the sample doesn't look like a mini version of the population, if you use the appropriate estimation techniques, such as weighting, probability samples can yield unbiased estimates of the frame population. So I think another way of thinking about what are the main insights from this framework is how you collect your data has to impact how you make your estimates. So a lot of what happens with sampling and estimation is you collect the sample one way, and then in the estimation stage, when you're trying to generalize back to the population, you have to sort of undo whatever distortions were created by the sampling process. And the second is it focuses much more on the properties of estimators, not the properties of samples. This is again trying to get away from this idea that the sample needs to look like a mini version of the population. So this is an example, crude example about estimating unemployment. So this is one sort of reason why the sample doesn't necessarily have to look like a mini version of the population. and you can use weighting to correct for that fact. So let's say we wanted to estimate the unemployment rate in the US, which is something we do all the time. So one thing that then a congressperson might say is, we don't want just a national level estimate, we want an estimate for each state. And so you, statisticians, figure out a way to give us an estimate for each state also. So then we would say, all right, if we just take a simple random sample of the entire US, then we won't have enough people from the smallest states to make a good estimate. So we don't get enough people from Rhode Island. So what we're going to do is we're going to select a similar number of people from each state. So let's say we're going to take 2 people from each state. Then that way we'll be able to make reasonable estimates about each state. But then this sample is no longer a mini version of the population. If we just take the average unemployment rate in the sample, we'll get the wrong estimate potentially, because we have as many people from Rhode Island as we have from Texas and California. So what we do is we use the relative number of people in the sample and in the population to sort of scale up each respondent appropriately. So we sort of, people, when we're making a national level estimate, these people from Texas count more in the estimate than the people from Rhode Island, because the people from Texas in some ways represent more people than the people from Rhode Island. So everything, this is all like standard probability sampling in textbooks. Everyone agrees this is totally kosher. So a way to write that down is the estimated, let's say y is the whether someone is unemployed or not. We can take, basically this is like a weighted average of all the sample y's, and then we divide by the number of people. So the key is we don't take a simple mean, we take a weighted mean. And this estimator is sometimes called the Horvitz-Thompson estimator or the pi estimator. It comes up over and over and over again, where you weight people by the inverse of their probability of inclusion. So people who are less likely to be included get more weight. People who are more likely to be included get less weight. Okay, so that's how it works in a book. You have the respondents and you have the information about how the sample was selected, and that gives you the estimates. In practice, you have information from the respondents and you have estimated information about the sampling. We don't actually know people's probability of inclusion. We have to estimate that based on auxiliary information, stuff like how many people live in each state, which is not in the sample. That's something we know from some other data source, plus some assumptions. And then this is how probability sampling works in practice. And again, this is how non-probability sampling works. We have respondents. We estimate some information about the sampling based on auxiliary information and assumptions. So here's, let's imagine we just put up an ad on, put up like banner ads on Yahoo, and we're like, we would like to find out if you're unemployed. Please fill out our survey. That's a sampling process. We could do that. We get a bunch of people. We might think, well, if I just take the average of these people, that's probably not going to be a good estimate. So maybe I'll try to adjust for the fact that people in some states are more likely to show up in my sample than people in other states. So I'll set up something like this where I get the information about the size of each of the states, and then I weight these people up based on the number of people that they're supposed to be representing. So the conceptual, this is the same picture you saw before, by the way. So you can see the logic is the same. The only difference is in one case, we know that these 2 people are randomly selected from all people in Texas. In the other, we're essentially assuming they're randomly selected from all people in Texas. And in the banner ad example, that's probably not a good assumption. But this, as you read about, can be expanded into multiple dimensions. So we'll say, well, maybe we'll assume that young people are more likely to be online. So we're going to split this up. We're not just going to have all people in Texas. We're going to have all people in Texas between 18 and 29, between 30 and 39, and so on. So right here, I've drawn this as sort of a one-dimensional way of splitting up the population, but you can also split it up in 2 dimensions or 3 dimensions, and so on. So another way to write this down is we sort of are estimating each person's probability of inclusion here based on the number of people in the sample in a certain group and the number of people in the population in that group. So what this means is you need auxiliary information about the size of the groups. You need the ability to place the respondents in groups. This may seem like an obvious thing, but I've heard of people who do a survey and then they come and they ask me a question. They're like, I want to do post-stratification. And I'm like, all right, well, what demographics do you have about the people? And they're like, oh, we didn't collect that. And I'm like, well, then you can't do anything we're going to talk about. So in all of your MTurk surveys, you will all definitely collect demographic information that will allow you to match to the auxiliary information that we've provided you, or else you'll have a very short and boring activity. And finally, this obviously makes some assumptions. Very crudely, you're kind of assuming that the people that you see in each group are a good representation of the entire group. So one way to think about what these adjustment methods are doing is they are bringing in more information. So that is how they are working. It's not like you're getting something for nothing. You're bringing in extra information and you're making additional assumptions. That's what's allowing you to make progress. So if this external information is wrong, or if the modeling assumptions you make are wrong, then you can make things worse when you try to do these adjustments. But I would say in practice, it usually seems to make things better. This is like, I'm not sure everyone would agree with this part, but in a lot of examples that I've seen, even if these kinds of adjustments don't completely solve the problem, they usually make it less bad of a problem. So let's just do a very simple example now, a quick example. It's actually, not totally simple, because there's actually two reasonable answers. So let's imagine we want to estimate the average height of Princeton students, and so we went outside of Parrotsman Scully Hall, and we recruited 60 Princeton students. 20 of them are men, 40 of them are women, and the men had average height of 180 centimeters, and the women had an average height of 170 centimeters. So what would we estimate then for the average height of Princeton students? So you can take a moment and think about it and talk to your neighbor. As I said, there's kind of two natural answers that you might come up with. Yeah. Okay, good. Okay, so this is a short activity. Fantastic. Okay, so you all have just done your first post-ratification adjustment. So one thing that some people think to do is the sample mean. That is kind of a very natural thing to do. If you have a sample, you just take the mean. But many of you realize, oh, wait a minute, I have some extra information. So I can use that to adjust the data and reweight it to get a better estimate. So you've just done a very simple post-ratification adjustment. Now, how could this go wrong? So this is not a magic solution, obviously. So if the people that like maybe you go and are outside of Parrotsman Scully Hall after the basketball team is coming back from eating, then obviously this post-ratification adjustment is not going to work because the men that you have are not representative of men on campus and the women that you have are not representative of women on campus. So although this seems like a great idea, whenever we do these adjustments, we have to always think about what it is that we're doing, what it is that we're assuming when we make the adjustment. Now imagine that you wanted to do the same thing, and you also said, but wait a minute, I know something else about Princeton, which is I know that a quarter of the people are first-year students, a quarter are sophomores, juniors, and seniors. And then further, you're going to assume that each class year is the same. Each class year is half male and half female. So then you could try to, again, split up your sample into those groups and do the same trick, right? Now, imagine, though, that there are no female seniors in your sample. So imagine
People keep getting taller at 22.
so first, second, third, fourth year, males and females. You split up your sample. You look at the average height in each of these groups. You know their relative sizes. You're going to do a weighted average. But imagine that you have no female seniors. You have no one in this cell. So now you can't do this weighted average anymore because you don't know what to put here. So what you might do is you might say, well, maybe I'll look at the relationship here and try to look at this here and project into this. Or you might say I'll do something like this kind of ratio and project this way. So now, congratulations, if you do something like that, you've done a model-based post-stratification adjustment. So now you've added this other assumption, though, that your whatever modeling trick you're using is true, and if it's true, then you can go forward. Yeah?
So, okay, so the first one was the cell-based adjustment.
Mhm.
This is the model-based adjustment. What is raking?
We'll come back to that later. So raking is so one thing that you'll encounter with cell-based post-stratification. Okay, so here's the idea. So if you want to do cell-based post-stratification, so I personally, that's always my first thought because it's the easiest to understand, right? And so if you start doing that, what you'll see, you'll run into this problem that you're going to want to create lots of cells. Because really what you want is you want each cell to be homogeneous, sort of. So that suggests lots of cells. But then, if you make lots of cells, each cell has not that much data, or potentially no data, and then things get very noisy. And so raking is a way of potentially trying to create lots of cells without, and borrowing sort of information across the cells, roughly.
In a different way than
In a different way than this. So a lot of these techniques have different, I think fundamentally what you're trying to do is, so yeah, raking, although the procedure is this iterative reweighting, there is a model-based way of motivating raking as well. They talk about the modeling assumption that underlies that. So that is how I would think about it. But I would say the first thing to try is always cell-based post-stratification. Then you will become frustrated by the amount of cells that you can have and the amount of added weight variability you introduce. So that you notice that concept came up a lot in the weighting article, was about weight variability. So let me try to briefly explain why people don't like that. So roughly, if some people in your sample, let's go back to the California, Texas, Rhode Island example. So here, we have two people who are representing all of the state of California. They have really enormous weights. And so who those two people are matters a lot for the estimate. And so what that means is there can be very high sample-to-sample variability, which is this. So because one time we pick the sample, we get an unemployed person in California, that will give us a big estimate. One time we pick all unemployed people, that will give us a much smaller estimate. So we don't want the estimate to change a lot based on one person. And so if we have high weight variability, then the estimates can change a lot based on one person, and that's bad. So there's this story about this online poll. Did you hear about that? Did you guys read about that in the New York Times? It was there was this one.
Oh, like the one black guy.
Yeah, the one young unemployed African American who, those people weren't in the survey a lot. So this one person was standing in for 300,000 people, and he liked Trump, and so a lot of the surveys were sort of skewed by this one particular person. So that's an example where one person with a lot of weight can create a lot of instability in the estimates. And so another thing that sometimes people do, this article talked a little bit about weight trimming. And so that's the idea of basically just saying no one can have that much weight, that's a bad idea. We're just going to cut their weight down a lot and spread it around to other people. So then you may say, well, that doesn't sound kosher. And what weight trimming does is it sometimes introduces bias into the estimates, but it can decrease the variance, and so it can still lower the error. So another thing is that some of these survey techniques, people are focused on what's unbiased, but oftentimes we should also really think carefully about what has the lowest error, because that's often what we care about. And so some of these techniques involve introducing a small amount of bias to decrease the variance substantially. Or some of the techniques that you will use may potentially lead to unbiased estimates under greater range of situations, but may actually lead to more variability in the estimate. So the weighting adjustments you do may increase the variance of your estimates. And of course you would need to capture that when you produce your confidence intervals. Okay. Is that good? So then that's basically what they did in the Xbox server. They just did a very fancy version of this. So this paper, I described it in the chapter already, so I will just say briefly, the demographics of this sample are way different than the demographics of voters because they took this sample of Xbox users, which is predominantly male and young. But they had 750,000 interviews from 350,000 respondents. Then this is the unweighted Xbox sample. So it goes up and down like crazy non-probability samples. This is Dewey defeats Truman right here. But we've learned a lot since 1948, including things about model-based adjustment. And so this is what happens if you add adjustments to the Xbox data. You get something very close to the final election result, and in fact closer than what you get from the aggregation of standard telephone-based surveys. So this was a very surprising result to people. Many people doubted this. This is a kind of a controversial paper, I would say. But I think there's two important points to this. One is this is not a good estimate. So I'm not saying like just take non-probability data, don't worry about it. That's what you get. I'm saying if you take non-probability, so that's point one. Point two is this line. If you take non-probability data and you do the appropriate adjustments, then you can get good estimates. Okay?
What's the source of controversy in that claim?
Basically, this one everyone agrees with. The second one is what I think people would say, and what some people said about this is you have no theoretical basis for knowing whether this will work and when it will work.
Which questions it's appropriate for?
Yeah, or what kind, because what you're doing, this is not my personal belief. Now I'm going to take the view of a skeptic about this. I'm a skeptic about other things. And I actually kind of believe this. So let me give the negative version of this paper. Okay, in this case, you have shown in a setting where you know a lot about what's happening, because we've done election polls many times, you have really good information that you could use for post-stratification, and you spend a ton of time building this very complicated model, then this can work okay. But is this going to work okay in the next election? Is this adjustment going to work okay if we did it in the UK, or in South Africa, or in Turkey, or anywhere else? Now, what this skeptic would say is, probability-based sampling, Horvitz-Thompson estimator, that works everywhere in the world without me having to know anything about it. Like in this survey we did in Rwanda, I didn't have to know anything about like the social structure of Rwandan society or different patterns of non-response, because we had a probability-based sample. We had basically zero non-response. We had like a 99% response rate, and we knew everyone's probability of inclusion. And so to make the estimates required no external information and no assumptions. That is a very, very attractive property.
But to calculate probability of inclusion, you need information about the population.
No, so all we needed actually was a map of Rwanda divided up into grid.
But how many people live here?
Nope, we didn't need that. So we actually collected that while we were going. So it was sort of divided into so we would pick a grid element, we would go there, and then we would enumerate all the housing units, and then we would take a probability sample from those housing units. So it did not require a national address registry or anything like that. So I think the claim, and this is part of, you can see this blog post, so after this, other people said a version of like what I said, that this adjustment there's no sound theoretical basis for. And Andrew Gelman, who is one of the authors of this paper, who some of you may read his blog, posted this: the president of the American Association of Buggy Whip Manufacturers takes a strong stand against the internal combustion engine, argues that the so-called automobile has little grounding in theory, and that results can vary widely based on the particular fuel that is used. So this is exactly what I was saying, right? Like, it's not a strong theoretical basis, depends a lot on a case-by-case basis. You can read this blog post for more about this. For some reason, this is a very emotional topic for some people. Have people experienced some of this in their research, this emotion around this? Okay, so that then leads to the paper that you read and what you'll do in your activity, which is they said this Xbox thing, this had like 700,000 responses, 350,000 unique people. Like, how far could you take this? Like, let's just, if these Xbox people who are clearly not in any way reflective of the population can be reweighted, what if we could do it with Turkers? And what if we could do it with a much smaller sample? That's what we're going to find out today. So a couple points about the Xbox paper. Mr. P, the reweighting technique that they use, this is just one of many ways to post-stratify non-probability samples. The performance of these is an empirical question. We should not assume that it works. We should not assume that it doesn't work. It's like a question. That's what we do research about. It's not decided by fiat. Related methods can be applied if you have digital trace data that's sampled with some unknown process. You can imagine trying related things. Also, as I said yesterday, with experiments, you can imagine trying to reweight the people in your experiment to try to recover population average treatment effect from a sample average treatment effect. There's a whole other set of non-probability sampling methods that I didn't talk about that focus on the sample rather than the weighting. So one of the things that you might have been thinking is like, Matt, it seems like what you're saying is, let's collect the junkiest data possible and then just fix it after the fact. And a good reaction to that argument is like, that doesn't make sense. Let's try to collect better data, right? Like, why collect junky data and try to fix it? Why not just collect better data? And so there are a variety of techniques that focus more on trying to get the sample to be better, and that is defined in, well, so one of these is quota sampling, which is actually a very old technique. There are more modern variations of it. Another is sample matching. So a lot of these online panels that you may have used before, like YouGov, they use a version of sample matching, and they use a version of these kind of weighting techniques as well. And we shouldn't let what happened in 1948 prevent us from trying new things today. I think that last point should be uncontroversial. So then sometimes people ask me, okay, I have to do a survey. Should I use a probability-based sample or a non-probability-based sample? And unfortunately, there is no one answer to that. So this is kind of how I think of the world right now. So here there's cost, higher cost, and lower cost. And here is error, more error, less error. Obviously, we would like to be here with low cost and low error. That's where we want to be. I think probability sampling in practice, there's a huge variability to those things. Like what company that you work with, how you implement these procedures makes a big difference in terms of the cost and the error. And I think the same thing is true for non-probability sampling. In fact, maybe this box should be even bigger because it includes a huge range of things. So I think it's impossible to say one is necessarily better than the other. If cost is a major criteria, then maybe non-probability sampling could be more attractive. I also think it's the case that there are some non-probability sampling methods that have lower error. A good non-probability sampling technique right now will probably have better error than a bad probability sampling technique. So basically this is some way of saying it's impossible to give a clear answer, but one thing, then the second thing is what do you think is going to happen in the future, right? Not just what is happening right now. So I think if you look at the trends, it's pretty clear that probability-based sampling, the cost will continue to go up. This is a very long-term trend. And the error will continue to go up because the non-response is going to continue to go up. I don't see either of those trends changing. So I think it's very likely this box will move in this direction, which is, remember, we want to go over here, right? This is where we want to be, low cost, low error. This is moving in the wrong direction. This, I think, is moving in the right direction. I think we're going to see a lot of development in terms of lower cost techniques and also ways of doing the sampling and the weighting that give us lower error. So this is my guess for the future. Yeah?
So it does seem that ultimately you are sympathetic to the Gilman Xbox paper, right? Like that.
Yeah, I am sympathetic to it.
So what would your response be to the skeptical version of yourself?
So my response to those people would be, I completely agree with you. If we can do probability sampling where the frame population perfectly matches the target population, and if we can have no non-response, then we should do that. If you can tell me how to do that, I'll do it. That is not the world that we live in right now. I would love for that to be the world that we live in. But in practice, we're not living in that world. So we're going to try to approximate that somehow, and that involves trade-offs. And given the trade-offs between probability sampling in practice and non-probability sampling, then I think non-probability sampling is attractive now and likely to become more attractive as it gets better and as probability sampling in practice gets worse. Probability sampling in theory is still the best and not going to change. It's great. That's how. Is that? Yeah. Yeah.
You expect that the probability sampling in practice will increase in cost.
Yes.
Why?
So
For
yeah.
example, we don't use any more papers to interview people. We just use the smartphone to do that.
Yes.
So that decrease actually the
Yes.
cost of those techniques, I think.
Yes, that's a good point. So some costs will go down and some costs will go up. So costs related to processing paper forms, that will go down as more and more of the data collection is digital native. And that's happening everywhere, right? Even using digital native in the interview process everywhere. I think the part about the cost that will continue to go up is driven by the non-response. So one solution that people have to non-response is just to bother people more. Like, I'll call more, I'll pay more money, I'll do all these things, and those things are expensive. So as the challenges of getting people to respond continues to get harder, the cost of trying to maintain a reasonable response rate will continue to go up. Yeah?
So as for the non-probability sampling, we need some adjustment. That means
Yes.
we need weighting.
Yeah.
That means weighting needs some reference, like a teaching
Yes.
data. I think if we decrease the error, we need more precise reference. That makes more cost, no?
That's a great question. So the key, a big important thing in these non-probability adjustments is the reference data. The cost of the reference data is not borne by the researchers. That's borne by the government. So in the US, we often use data from the census to do these adjustments. So one thing that comes up is there is an argument out there that, like, federal statistical agencies, we don't need them anymore because all this other data is being created. And I think it's exactly the opposite. That we need them now more than ever to give us these reference values. So if we invest a lot in official statistics, creating very precise, high-quality reference values, that can unlock value in lots and lots and lots of other data. So that's my argument for increased funding for the Census Bureau. Which, by the way, I should just to clarify, that is actually where I started my career. That's where I had my first job. So I'm not unbiased. Yeah.
So you asked a question earlier about the sort of emotional nature of the theory question, and I think, at least in social work, it's a question I get a lot, particularly when it comes to using digital trace data, and like, well, it's great that we have a lot of data, but just because we have a lot of data doesn't necessarily mean that it's right. What's your personal sort of response to that?
Again, I totally agree. So like I think in general, a lot of the skeptics of a lot of this is so I guess there's a specific and a general. Like the specific thing is I would agree. And so the challenge is to think about what we can do with this data and what we can't do. And like clearly there are some things we can do with it, and there are clearly some things we probably shouldn't do with it. And so it's more than like battling over whether it's bad or good. We should try to figure out how we can use it responsibly. And so I think like weighting is not going to magically solve these problems, but it's something that we can do to help with the data, the digital trace data that has unknown sampling process. Also, in general, thinking about it in terms of what's the target population, what's the frame population, what's the sample, who are the respondents, that can help clarify exactly what people are concerned about. Because I think a lot of times, more generally, when you do some kind of computational social science thing, people are just generally concerned and they don't often have a vocabulary to express that. They just feel like something is wrong with what you're doing. They can't really put their finger on it. And so if you can give them a framework to think about it, like, okay, so is this your concern or this or this or this? Oh, this is your concern. Oh, let me tell you how we could address that.
Well, I think just to follow up in terms of social work, one of the complicated things is that we care mostly about the margins. So we care about the people that aren't talked about. So for example, when you think about gender, we're concerned about, well, what about people who are non-binary and, gender non-conforming and so forth. So because we're always concerned about those people, it's hard to, so far I've found it difficult to make the case because of the problem of demographics. But looking into the new work that's being done in that area, things are starting to, there's at least a conversation.
Yeah, so let me just turn that on its head though and say, if we care about very rare populations, then we need really big sources of data to have enough of those people.
Right.
So there's the trade-off, right? It's true that we don't know exactly how these people entered into our sample, but potentially having enough of them to describe the characteristics of even the ones who are in our sample might be useful for populations that are rare and at the margin. Yep.
I'm just wondering if you could apply the same kind of weighting to observational data.
Yep.
Like, say your observational data is coming from a weird sample of the population, but you actually know what the target population is.
Yeah, absolutely.
Has
absolutely.
that been done?
Has that been done? I'm sure it has been done. I mean, all the, if you know the probability of inclusion, that's it. I mean, all of the math goes through. Like in animal populations, for example, this is not surveys, right? They like count animals in certain places, and there, if you know the probability of inclusion of a certain animal in your count, then you can upweight that animal to get an estimate for like the total number of animals. So yeah, you can definitely do that. Curtis? Oh,
Sorry.
yeah, okay.
I was just curious, where does RDS fit in here? Are there any solutions that we would change this calculus based if you were using RDS and say non-probability?
Yeah. Okay. So RDS is respondent-driven sampling. That's something that I've worked on and others have worked on for studying hard-to-sample populations like drug injectors and sex workers. And it's a network-based sampling technique that is, rather than you, the researcher, selecting all the people, you find a few members of the population, you have them recruit their friends, and then they recruit their friends, and then they recruit their friends. So it's similar to what social scientists used to call snowball sampling. So it turns out that under certain conditions, you can take the data that comes out of this and weight it and get unbiased estimates if those conditions are met. So about how does respondent-driven sampling fit into this? So I would say, like, respondent-driven sampling should be avoided if at all possible. But often it's not possible, right? So when the CDC or other ministries of health, they ask for help about, they want to study these groups that are most at risk for HIV. And they say, like, okay, we need to make estimates of, like, what percentage of drug injectors in New York have HIV. And I say, well, like, that's a really hard problem. And they're like, well, we need to do it. So what's the best available thing? And I say, okay, what's the best available thing? I think is RDS, respondent-driven sampling. So I think the model to think about some of those is more like a medical model where like you go to the doctor, you have cancer, the doctor tries to help you the best the doctor can and doesn't just say, well, sorry, we don't know how to deal with that, come back in 10 years, right? You just kind of do what you can with what you know how to do. But it's not really a first option. I think the best thing is probability sampling in theory. And if you can't do that, then you're in the realm where you're having to make trade-offs. And for those particular populations, I think it's a reasonable trade-off. Yeah?
I'm curious about the process of determining which auxiliary variables one should use in post-stratification.
Yes.
Because for me, that's like a big issue here.
Yes, that's totally right. That is the art of it. I would say, so there are certain theoretical results, but in practice, it's usually based on convention. I would say you want to take this one?
Yeah, sure. So what we usually try to do in all sorts of non-response adjustments, we want to go for those variables that we think are related to the non-response process and to the outcome variable. Of course, if we have an entire survey, that's where it then becomes difficult because, of course, the non-response bias is a survey-specific statistic or a survey-specific, statistic-specific problem. But the idea is, again, to focus on those variables that explain both, that are related to both, if you want to successfully reduce bias, because otherwise you're just going to increase variance.
So let me explain highlight one thing Antje just said, is about the difference between the things that are related to the non-response process, which is true for all the questions in the survey, and then the things which are correlated with the survey response and the response process. Those are question by question specific. So another critique of the Xbox paper is you really only had one outcome, so you're able to craft a custom adjustment scheme for that outcome. And in a lot of general purpose surveys, you have to create one weighting scheme for all the questions. You can't create a separate you could create a separate weighting scheme for each question, but no one does that.
Yeah.
So that is another way in which that particular paper, some people might say, even though that result is true, that's not very generally useful because we often just create one weight for all the questions.
Can I ask a follow-up?
Yeah.
So a lot of the times for this kind of stuff, the frame population is coming from something like you said, the census.
Mm-hmm.
And I'm just wondering that, so censuses are decennial, they happen once every 10 years. Things happen between,
Yes.
Especially if you have a huge wave of, say, refugees entering the
Yes.
population. So in that sense, we often see probably people would use the American Community Survey.
Yes.
Which is also a survey.
Yes.
So I'm just wondering about sort of what does it mean to weight against the survey in the absence of frequently updating data? Because of course censuses are different.
Yeah.
They're 100% as far as we can tell.
As far as we can tell. So I would say, again, this is a case for having more frequent large-scale measurements by the government. We should have a census every year.
Or get administrative data.
Or get administrative data, or do other things. But it's true that if the information that you're using, if the auxiliary information that you're bringing is not correct, then this is not going to work as well. That's true. And then what it means to use the auxiliary information that comes from a survey versus would you rather use the ACS or a 5-year-old census? I think it's hard to say in general. The best thing is the most accurate and most complete auxiliary information. Yeah?
So I'm having trouble thinking through what kinds of questions this technique is good for and what it's not
Yes.
good for. I mean, the obvious answer is that it's an empirical question. We have some ground truth. And
Yes.
But is there any way we can say something systematic about the kinds of questions that it would answer well? So for instance, I'm trying to imagine using this technique to estimate, say, crime victimization or something
Okay.
like that. Now that's an extraordinarily rare outcome. So the likelihood that you could poll 1,000 Xbox users or something and get enough granularity in individual cells, you'd be unlikely to see outcomes in most of the cells if you split it up. So is it perhaps questions that have very rare outcomes that is one subset of questions for which this kind of technique is unlikely to be useful? Or is that just resolved by polling 300,000 Xbox respondents? Okay,
so rare, I think there's two questions. I think rare is raises special issues. So one is, in general, what kinds of things does this kind of adjustment help with? I think it's very related to what Antje said with. It helps when you have the data that you need to model the response process and or model the answer that people give. If you can basically break the population up into groups such that you can estimate this group mean well and there's not unobserved heterogeneity. So like in the Turk case, for example, which you're going to work on, as far as we know, everyone who's on Turk has access to a computer. I mean, I think we know that for sure. So things that are related to computer use, a male 18 to 29 on Turk might be different than a male 18 to 29 not on Turk. And you could add in education, and you could add in geography, and you could add in all these other things, but fundamentally we know that technology use and Turk is a special thing, but other things like attitudes, like maybe it's the case that the attitude of an 18 to 29-year-old male Hispanic person who went to college on Turk is similar to the attitudes of people who So this rare populations is just generally a problem in all survey research. And again, then I think those populations are ones where having really big samples really helps. Because then you have enough of these rare people, and then you can potentially do stuff with them.
And that's easier to do with these techniques, hypothetically.
Yeah, the cost, because the cost per unit data is lower, then you can potentially have much bigger samples, which allows you to capture these rare people. Another approach for rare people is to go like sample in a certain area where they're more likely to be. But then that introduces other kinds of issues.
And rare people and rare outcomes are basically the same issue?
I would think of, in your setting, I would think of you're looking for people who have had some experience and they're rare.
Right, okay.
Okay, any more questions? Yeah.
I have a question about choosing the cell. So
Yeah.
if you're dealing with continuous variable like income or age,
Yes.
how do you choose the cell size?
That is a great question. So often people, by convention sort of, like there are standard age categories that people use. There are other techniques which we haven't learned about, which allow you to use continuous things. But those are a little bit harder to understand. So we're going to start with this. And you basically choose the categories based on convention, is what I would say. Or, that's not totally fair. Or you would choose them based on the response probabilities. Choose them in such a way, like, for example, people who are like, you might think like people who are 65 plus are different than people who are, like, you might try to pick the categories based on what you believe about society. Like, once you're over 65, you're maybe more similar to an 85-year-old than you are to a 55-year-old, let's say. So, right, you're building some ideas about society into how you create those cells. Two questions.
Matt, can I just tell you we're a half hour behind schedule
Okay.
right now? I just want to give everybody.
Okay. Is that what you wanted to say, Yoga?
No.
Oh, sorry.
You want to say something else?
I would just say if you use the generalized model-based frame, it doesn't matter if you put it in as a discrete variable or a continuous variable, but it just carries different assumptions for the bias of your estimation. But you can enter the variable as a continuous.
Okay, so let us have a coffee break, and then we will move on to the next part of
Maybe a 5-minute break.
a 5-minute coffee break, and then we'll move on to the next part of the third era of survey research, computer administered interviews and wiki surveys.